Hi, questions from people on question number 9 and question number 15 from section 9.9. So I'm going to take a look at those, and I do have a couple of others which will be in another video. All right, question 9, they give you a few different triangles here. They ask you to find the cosine of angle A, the sine of angle E, which is over here, and the sine of DFG, which is this angle right here. All right, let's take a look first at the cosine of angle A. For right now, the only trig we know how to work with is right triangle trig. So if they don't give you a right triangle, you're going to need to make a right triangle somewhere. Notice this is an isosceles triangle. You know from the proofs part of the year, if you drop an altitude into an isosceles triangle, you can create two congruent right triangles. So what that's going to do is it's going to give me a side length here of 7 and a side length of 7. Okay, so had we not done section, I think it was 9.6, you'd have to do the Pythagorean theorem, and you'd have to do 7 squared plus this side squared is equal to that side squared. However, we know Pythagorean triples, and they're really powerful, and they're all over the place. They're going to continue to be all over the place the rest of the year. We know this is a 7, 24, 25 right triangle, so we've got the altitude there, all right? They ask you for the cosine of angle A. At that point, we don't even need the rest of this triangle. We can really just look at the one right triangle that we have. Remember that cosine, if you use your SOHCAHTOA rules, cosine is adjacent over hypotenuse, okay? So we're going to go to angle A. The leg adjacent has a length of 7. The hypotenuse was given to us. It has a length of 25. That's the cosine of angle A. So remember, if they ask you for a sine, cosine, or tangent, it's just a fraction, unless you get it off your calculator, and then it'll be in decimal form. All right, number 2, sine of angle E. That's over here. They were nice enough to kind of give us a hint about what was happening here. So the original triangle is obtuse. Again, it's got to come back to a right triangle. They suggest dropping a little altitude down in here and kind of boxing this triangle in. And if you extend this side out, you can see there, that's actually the altitude of triangle EDF. And so you can make a little right triangle there, okay? I didn't see anything at the start. You know, I'm kind of looking at angle E here. And I really need all 3 sides of that big right triangle. I don't have all 3 sides of that right triangle. But I noticed something else. There's another right triangle. Okay, there's this triangle here. And notice, we've got side lengths of 6 and 10. That's a 6, 8, 10 coming from a 3, 4, 5 pattern double. That's a 6, 8, 10 pattern. Notice triples all over the place here. And so I actually think we're going to be able to find the sine of DFG faster because we've already got all 3 sides of that triangle. So anyway, in this particular case, that is a 6, 8, 10 triangle. We want angle DFG, which is this angle right here. We want a sine. Sine is opposite over hypotenuse. So we go to the opposite side, we go to the hypotenuse. That's going to be 8 over 10. Okay, your 3rd grade teacher will want you to simplify the fraction. Make sure you're simplifying fractions. Sine of DFG is going to be 4/5, okay? They don't ask for the angle measure, they just ask for the fraction. All right, I'm going to jump back to sine of angle E now. So now I've noticed in this triangle, I now have 2 out of 3 sides of the big right triangle. So again, had we not done section 9.6, you'd probably just have to use the Pythagorean theorem, but we know that there's an 8, 15, 17 right triangle, and so that whole side there is going to be 15. Yet another Pythagorean triple, they're huge. And we want the sine of angle E, okay? So sine, again, is opposite over hypotenuse. We're now looking at the big triangle. You got to be looking at the right triangle that involves angle E. The opposite side is the 8, not the 10. That's an obtuse triangle, that's not right triangle trig. So it's the opposite leg of the right triangle over the hypotenuse, and that ends up being 8/17. All right? We also had a question about number 15. Number 15 gave you a trapezoid, and we know, of course, in geometry, step number 1 is always to make sure you've got a good diagram, so hopefully you've drawn that. A little bit of common sense there suggests that those 2 sides of 10 need to be the 2 sides of your trapezoid, which, by the way, means it's an isosceles trapezoid. And we want the sine of the acute angle. So we're looking at, I'm going to label this angle A down here. So sine, once again, sine opposite over hypotenuse. A lot of sine questions here. So we're trying to find opposite over hypotenuse. We're trying to fill that in. On the surface, you look at this and you say, there are no right triangles. How am I supposed to do right triangle trig? And the answer is something that's going to be very important in the next unit. creating right triangles by dropping altitudes in. So, you know, a height would normally go right here and it would hit the base at a right angle, but there's no reason you can't drop an altitude over here, okay? And although we only care about that one right triangle, we need some measurements on these sides, and we've got the 17 down here. We need to do something with that. So I would suggest dropping an altitude down on this other side. And of course, we know for an isosceles trapezoid that we're going to get two congruent triangles here. That whole side was 17. If this is 5, that's going to be 5, because that would be a rectangle with the parallel lines and the perpendicular sides. So 17 minus 5 is 12. That leaves us with 12 units that need to be evenly broken up here and here. So 12 divided by 2 is 6, and 6, and so notice 6 and 5 is 11, plus 6 is 17. That's how this is going to break down. And then notice what happens. We've got a little 6, 8, 10 right triangle there. We've got all three sides labeled. Should be able to find a sine very easily. Sine is the opposite side, or the opposite leg, over the hypotenuse. That's going to be 8 over 10, and looks like we get another answer of 4/5. Hope that helped on number 9 and number 15.